1 minute. 1 minute. And Micaiah, you done?
I'm sleeping.
This is right. Don't be embarrassed.
I am looking at Miss Paletti.
Perfect. All right. Everyone's got credit. Jordy, I got yours, right? All right, good. All right. Raise your hand and tell me, what would be a good title for this graph? Paul.
Hi, Greg.
Okay. Elizabeth.
Speed versus time.
Good. Speed versus time. You can make your own title. What goes on the y-axis? Raise your hand.
Speed.
What goes on the x-axis? Good. And then you fill in the coordinates. Your line should look like this. It is a constant speed. Remember, if the line is straight, diagonal, it's constant. If it's horizontal, it's not moving. Okay? Now, most objects don't move in a constant speed unless you're on cruise control in your car. Most objects don't. If you're running in a marathon, you're probably not going to have a constant speed. You're probably going to run fast, then you're going to run a little slower, then you might take a break, then you might catch your second wind and run even faster for the second part of the race. Now, raise your hand if you think you know how to do slope for this line. What'd you get? You didn't do it yet? Okay, who did it? Besides Stephanie. Anyone else?
Jolene.
Did what?
Slope for this line.
Oh, what?
All right, Stephanie, what'd you get?
I did 10/5, and the slope equals 2.
Perfect. So you picked this point and this point? Okay. You can pick any two lines, any 2 points on this line. I could pick these 2 points, these 2. I can pick these 2 points. She picked these 2 points. Okay? So what you do is rise divided by run. You have to use your coordinates though. I can't say 1, 2, 3, 4, 5. I have to do it by 10 because the coordinates are going by 10. If I pick these 2 points, I can't say I rise 1. The coordinate is 2. So I rise 2. Then you go and you run. This one's going by ones. Okay, so if I pick this point and this point, I rise 10. I run 5. And then I divide. 10 divided by 5 is 2. Okay, now the book picked 2 points. They picked this point and this point. From 4 meters to 8 meters, I rise 4. I ran 2. 4 divided by 2 is 2. So no matter what 2 points you get, the slope is always going to be the same. The slope is 2. So if you got that, go ahead and write that down. Is there any questions about slope? If I gave you another line, could you figure it out? No? Okay. Come on. Come up here. Alright, pick any 2 points on this line.
Justin, put the camera on.
This is a point, this is a point, point. Pick any 2 points. Any 2. You can pick 10. These 2? Okay, how many am I rising, or how many am I going up from here to here? 4. How many am I running? From here to here. 2. So what's 4 divided by 2? There you go.
Woo!
Okay.
Carolissa.
All right. We have a lot of things going on today, so bear with me. Who can help me pass these out?
Let Corey help you. Come on.
Corey
Yeah.
and Julia.
Julia.
We have a lot going on, so you really have to pay attention. First thing you're going to do is you're going to glue your learning goal scale onto page 76. So open up your notebooks to page 76. If you need glue, raise your hand.
interactive notebook with lots of pages and things. That's the thing. Just Patty, do you want me to zoom in on like the notebooks to see like what you do? These are some notebooks. Here's some really good notebooks.
You're so hungry. It's this.
There's no talking.
This is the interactive notebook. This is where we do our work, and that's Jarlene.
Okay. Alright. Open up the 76 and glue in your learning goal scale.
Want to be cameraman, Justin?
You said every 20 minutes? Can you shut up? Miss Blood, you said every 20 minutes?
Yeah.
What page you glued on?
76, it's on the board. Okay, so page 76, glue the learning goal scale. If you have a question, please raise your hand. There's no talking, Julia. Alright, the next thing you're going to do, after you glue your learning goal scale to page 76, on page 77, I want you to write AHA Connections, Chapter 9. Yeah. Mm-hmm. Yep. AHA Connections, Chapter 9. Alright. We're going to move pretty quickly today. Alright. We're done with Chapter 8. We took our Chapter 8 test. Now we're on Chapter 9. Chapter 9 is pretty elementary. You learned most of it already, so we're going to pretty much fly through it. It's about forces. Okay? First thing I want you to do, I'm going to have you stand up, pick a partner, grab hands, and apply force to each other. Go ahead and get up. Pick one partner and apply forces to each other. Wait, what are you doing? Alright, so you should be doing this.
Damn it.
Okay? Apply force. Alright?
Let's do it, Jarlene. Stop. I won't record you.
What are you doing, Jesse?
Whoa, okay. Alright, once you're done, take a seat. Good. Okay, good. We gotta take a seat. Alright, take this paper out that looks like the notes. Okay? That one. Yep.
This one?
Yes.
The one that has 1, 2 on it?
Yep. Okay. Here's my question. Alright, when both of you guys were pushing against each other, why did neither of you move? Raise your hand. Paul.
I moved.
Perfect. Yes, because you were both moving with the same amount of force. Now, Corey, what would happen in order to get one student to move?
One person applies less force.
Correct. Or?
The other one applies more force.
Correct. Perfect. Okay, and last question. What would happen if one person stopped pushing completely? Kara.
They would fall.
They would fall. Is that what happened?
Brian
that was Brian and
Samita.
Samita. Oh, okay. All right. Good. What I want you to do is write down one thing you learned just now from that activity next to number 1. Okay? So it says, describe what you learned from the push-pull activity you completed with your partner. So maybe you learned when forces are the same, no one moved. Or if one pushes with more force, the other one moves. Okay? Anything you learn, anything you write is fine. Okay, perfect. Alright. You know what? Don't even pause it. Let's just keep the whole thing rolling. Alright. Now, we're going to go ahead and do PowerPoint. Instead of having you write in your journal for your notes, you're going to fill in the notes as we go. Alright, so this is a little bit new for us. We haven't done it in a while. So when I put the slide up, you're going to look at your notes and you're going to fill in the missing words, basically. Alright, if you get stuck, just raise your hand and I'll help you. Okay, don't call out and say, what are we doing? What word are we filling in? Raise your hand nicely and then I'll assist you. Alright, so we're on our notes. It says number 2, PowerPoint. Forces are a push or a pull. So you're going to fill in those missing words. And if you combine a push and a pull, you have a twist. Okay? Very elementary. I think you've learned this already. When one object pushes and pulls on another object, the first object exerts a force on the second object. So if I exert a force on an object, it's going to move. Okay? If I have more force than the object. Okay, so we're not writing in our journal. We're just going to fill in our notes. Help your neighbor. Alright, this is not on your notes, but it's important. You need to know forces are described by strength, how strong the force is, and direction. What direction is the force pushing or pulling in? Okay, am I pushing you to the left, to the right, up, down, etc.
So what do we write?
That one you're not. Okay, so just fill in the missing words. Alright. Objects are stationary when forces are balanced. So when you and your partner were pushing on each other, you were stationary. Remember the word stationary? Remember the word stationary means you don't move or you stay still. If the forces are balanced, you are stationary. Okay? And this picture is basically showing, two people pushing on a box. The box is not moving because the forces are balanced. Alright, forces can be measured using a Newton meter. A Newton meter is kind of similar to when you go to Publix and you're in the vegetables.
You put the apple on it and then it hangs down.
When you're at Publix and you're in the vegetable section and you want to weigh an apple or whatever and you put it on the scale, same kind of thing, except for a Newton meter will tell you how many newtons of force that object is capable of. So you just filled in Newton meter into your notes. Alright, unbalanced force was like Breyer and Samita when one of them applied more force than the other and it caused one of them to fall over. Okay? So if the forces are unbalanced, it is going to move. If the forces are balanced, it's not going to move. Balanced, stationary. Unbalanced, move. So I have more force than this bucket. When I apply force to it, the forces are unbalanced, the bucket moves. What happens when something moves? It gains kinetic energy. So it says, an unbalanced force causes changes to object's motion. If a force acts on a stationary object and causes motion, the object gains kinetic energy. Now, friction is when two objects are rubbing against each other. It doesn't necessarily mean your two hands. Okay? This box has friction against the counter. This soap has friction against the counter. My feet have friction against the floor. Okay? Friction causes objects not to move. The more friction an object has, the less it's going to move. Use that hand. Please. Thank you. So fill in the word friction. A Newton meter is a tool, like a scale, and Newton is a unit, like grams.
So it's an unbalanced forces cause changes to
Corey,
object's motion, right?
I'm going to write you a warning if you can't raise your
Is it
hand.
motion?
Raise your hand. Yes.
Is it motion?
is what motion?
This.
Newton meter.
No, the one under that.
Yes. Alright. There are two types of forces. Okay? A contact force is a push or pull on one object by another object that is touching it. We all know what the word contact means. Okay? Touching. Okay? So there's two types of forces. Contact forces, non-contact forces. Forces that touch, forces that don't touch. And we're going to go over the three types of contact forces, three types of non-contact forces. Okay, and by the end of it, you're going to have to know which is which without using your notes. So, pay attention. Non-contact force act at a distance. So if I say on a test, which of the following types of forces act at a distance, you have to know I'm talking about non-contact forces. Okay, so non-contact, acting at a distance, mean the same thing. This is not on your nose. Okay, that was a typo. I should have put it on there. Alright, here's the three types of forces. Friction, applied, and normal. Friction we just talked about. It exerts force when you rub against each other. The force of friction opposes motion. Oppose comes from the word opposite. Okay, so it stops the movement of objects. Alright, applied force is when you purposely apply force to an object. So if we're doing tug of war, you're purposely putting force on that rope because you want to win. Okay? If I move my projector down, I'm purposely applying force. Now, normal force is force that occurs without you even trying. And it has to do with being perpendicular. Okay? Now, the way I remember perpendicular, it's like a T. Okay? Or an upside down T. This alarm clock is perpendicular to this computer. My body is perpendicular to the floor. It's like an upside down T, right? So I'm not purposely stomping on the ground. Or I'm not purposely putting weight as I stand. But there is a force there. Okay? It's a normal force. It's without effort. Okay? So standing on the ground, books on the desk, those are normal forces. Now we have non-contact forces, electrical, gravity, and magnetic. Electrical, two objects that are electrically charged. We haven't gone into atoms, we haven't gone into subatomic particles too much, but I'm sure you've learned it a little bit in elementary. Electrons are negative, protons positive. It's easy to remember, P for proton, P for positive. Neutrons, neutral. Don't think neutron negative because they both start with N. The best way to remember it, neutron, neutral, no charge. And then we have electrons that are negative. Okay? If I have two electrons, they repel. Okay? Because they're both negative, they are not attracted to each other. If I have a positive proton and a negative electron, they attract. Okay? Now, they're not technically in contact, but there is a force between them. Alright, gravity. If I take this ball and I drop it on the floor, gravity isn't technically touching the ball, but there is a force there. Okay, so gravity is a non-contact force. Alright, and then magnetic force, which I'm sure you played around with magnets before. You take the negative and you try to put them together. They're not touching, but you can feel the force between them. That's not letting them stick. Okay? And you can feel the force of a positive and a negative magnet. They're trying to connect. You can feel it. Okay? Even if they're not touching. If you hold them a little bit apart, you can feel them trying to attract each other. Okay? What I want you to do without looking at your notes, I want you to fill in this graphic organizer without using your notes. Yep.
But it says distance.
Okay, so if it says distance, it means non-contact, same thing. Okay? You can write non-contact.
Distance make it easy.
Whatever's easier for you. Okay? So we're on the back of our notes. There's a graphic organizer. I want you to fill in all 6 types of forces. Okay? Without using your notes. If you get it wrong, you'll cross it out and fix it.
Can you check mine as well? See if I got it right. Yep.
So we just finished a whole section of the book that quickly because you guys already pretty much know this. So we're going to fly through the rest of the book this last 9 weeks.
Fly.
Perfect. Alright, gravity. Lisa, what is it? Magnetism, Jordy. Magnetism, contact or non-contact?
Non-contact.
Perfect. Paul, applied force. That's right. Friction, Leanne. Contact. Electrostatic, Kara.
Non-contact.
And Breyer, what's normal force? Contact or non-contact? Good. Alright, that's it for the note portion. Now, what I want you to do is I want you to close your textbook. And I want you to take your finger and I want you to try to move your textbook with one finger. Then I want you to stack 2 books and try it with one finger. And then 3 books. You can use partners to do this, okay?
No, get away from me.
I'm gonna try. Woo! Good job.
Okay?
Do that again, Chance. Do it for the vibe. How about you guys? Let's see.
Yeah, 3.
Julia,
One finger. You can do it long ways.
let's see you
if
guys.
want,
Come on.
Or that
Yeah,
way.
Mavisa, the muscles.
Alright, here's my question.
That question.
It's on your notes. Under your graphic organizer, it says, attempt to push 1 textbook, then 2, then 3, across the desk using only 1 finger. Why was it difficult to push the stack when more books were piled? Raise your hand.
More friction was applied.
Okay. Anyone else?
More.
More Newtons? Okay. What's an easier answer?
More weight. It's heavier.
It's heavier, more mass, more weight. Good. So write that down. Alright. Once you're done with that, I want you to put pencils underneath those 3 books and try to push it again.
Yeah. 4th grade. Yeah, journal. I got. This is where we keep our books and our journal.
Put pencils underneath the book and then try to push the books across the table.
Oh, nice, Carolissa.
Who's in my book?
Hold your control,
Look, my nail's gonna go through the paper.
Guys, look, we're never spread out. Right.
Okay, here's my question for...
It makes it easier.
What?
It makes it easier to load because less friction.
Alright, Kara, was it easier or was it harder when you put the pencils underneath the books?
Easier.
Louisa, do you think it was easier or harder?
It was easier because the less friction.
Right. It was easier. Why? Because there's less friction. When you put the pencils underneath the textbook, less of the book is rubbing against the desk, which is friction. Less friction, it moves faster or it moves more. Okay? Go ahead and write your answer down. When you're done with that, you're gonna fold the edge of your notes. You're gonna put the glue, and you're gonna glue it onto page. Nope, not 77.
78.
Not 78. 79.
Blue one on 79.
Your notes. Make sure I can see both pages. Tomorrow, I'm going to walk around. I'm giving you a grade for page 73, 74, 75, 78, 79, and your AHA that you're doing today. Okay? We're doing it today. Alright. When you're done gluing in your notes, I'm going to give each group 2 straws and 1 ping pong ball. You're going to read the directions for the air soccer lab, and then you're going to do it. Now, the first thing you're going to do is you're going to take your straw. Now, once you put your mouth on it, don't let anyone else use that straw. 79. So, what you're going to do, you're each going to have a straw. Well, 2 people in your group are going to have a straw. And you're going to have 1 ping pong ball. And you are going to blow through the straw onto the ping pong ball. We know the ball is going to move, okay? That's a non-contact force. You're not touching the ball, yet a force is being applied to it, causing it to move. After that, you're going to each blow on the ball from opposite directions at the same time. Okay, and you're going to answer those 2 questions, okay? So,
Stop laughing.
get out your air soccer lab report. It looks like this. You're going to read the directions. You're going to answer the 2 questions. I want you to try to stay seated, or at least, no running around the room, okay? Just stay seated. You should be able to be seated through the whole lab. No, just stay in your general area, okay? If there's 3 people, one's gonna do the observations, alright?
I'm gonna adjust.
Alright, Kara, come on.
No, I'm in my high group.
Uh-oh, I'm so sorry. I'm the pilot. Stop, you put it so close.
Alright, Chance, come on up.
Chance Dixon. Woo!
We need one more.
Ian, go up.
Alright, Chance.
I'm Justin, by the way. Do for the vine.
Alright, and Patricia and Jamie, come on up. And Louisa and Stephanie.
Come on, say it again. I ain't gonna do it.
Jolene.
Okay. Give me the ball. I do all of them. Like I said, stay in your general area.
Oh my God! Get the camera from over here. You always do that.
I'm filming Chance.
Okay. She like. Hey, get that shit away from me.
Definitely video the ones that are doing the lab, okay?
I won't film your faces. Just the
Read the directions, complete the lab, answer the 2 questions, and then we're going to share our answers.
Alright, what are we doing, guys?
I have no idea.
Good job, Emily.
I know Julia would do something.
I said, I'm not. Where are the straws? Scissors, your notebooks, the tape,
That's a lot of work.
and we're folding it into the notebook.
Now, when it asks how far does the ball move, I'm not asking for specifics.
Wait, is this your tape? No, you.
Alright, so you guys try to blow going at the same time in opposite directions.
Let's see you guys.
Try it again.
Try it. 1, 2, 3, go.
All right, try to blow it with the equal force.
1, 2, 3, go.
All right. Perfect, just like that.
Their group needs another one.
I don't have any other ones.
Good job, you guys. Get it, Emily. Good job. Way to be there. Patricia, you're always great. Oh, Bugappa. Gravity. Pulls it down. That's okay. That's what they did to ours.
I'm waiting. I have 3 more balls I'm waiting for.
Do not shoot.
Justin.
Take a seat, back at your seat. I'm missing one more.
Oh, I have one.
Throw away your straws, please. Corey, back to your seat, please. I'll wait. I'll wait. Alright, let's go over our answers. Alright,
Animal cell.
we're at our seats. I want you to raise your hands when I ask these questions. How far did your ball move? Across the table? Okay, good. A few feet maybe? Depends how much force you applied. Alright, so the ball moved a few feet when it flew through the straw. You don't have to write what I'm writing. Write your own answer, your own words. Alright, good. And the second question. Remember, you are getting a grade for this tomorrow. What would happen when both partners blow at the ball at the same time in opposite directions? If the ball didn't move. Okay, good. Now, a more scientific answer is the ball did not move because both non-contact forces were balanced, causing the ball to be stationary. Okay? The ball did not move. Why? Because the non-contact force were balanced. When you have balanced forces, the object does not move. Same thing as saying stationary. When you're done, you can go ahead and glue this into your book, page 78. I do want you to do the exit ticket. Okay? The exit ticket says, for number 5, the exit ticket says, have students describe how the force of pulling a book across a desk is similar to that of a book falling on the floor. How are the forces different? Anybody want to raise your hand and answer that? Wait a second. Patricia, move your seat. Move your seat. Go ahead, Sunita.
It still uses force to get it across the table and to get it down. But for the second question, it's different because when the book is falling, the gravitational force is making it go down.
Good. So when you're moving a book across a desk, you have a contact force. What contact force is it? Moving a book across a desk. Friction. What else? Applied force. When I drop a book on the floor, we have gravitational force, which is a non-contact force. Go ahead and write that down.
How are they similar?
Huh?
How are they similar?
How are they similar? They're both forces. Okay, but one's contact applied, one's non-contact gravitational. Now, when you're done with that, you're going to write 3 sentences of what you learned today on your AHA connections. Then, you're going to go to your learning goals scale. You're going to write today's date, and you're going to write what activities today helped you. And it's all on your Air Soccer Lab report, number 6, number 7. So what was it? Air Soccer, AHA, notes, hands-on activities, graphic organizer, discussion, exit ticket. Write your answer on the learning goals scale with today's date. Do your AHA connections, do your exit ticket. And if you forget one of those things, it's on the board. After you're done with all that, I will check it, and I will tell you it's okay to pack up. Not till I tell you. Alright, that's it. You can
Miss Paletti's 4th period class.